the introduction session for SQL Server for data analysis. I hope you are having a good day and you have managed to install SQL Server and restore the AdventureWorks databases. So someone may have heard about SQL or encountered some instances where you were supposed to use SQL, or you are a beginner, or you are yet to refresh yourself. So this course is going to help you to achieve all those objectives. Okay. So the question may arise to say, what is SQL? So SQL is short for Standard Query Language, and SQL is mainly used for database to manipulate databases, and is the language for databases. We have various databases that we have, for example, Oracle, Microsoft SQL Server, MySQL, MariaDB, among other databases, which are structured databases or relational databases. So SQL is used to manage and query relational databases. It's the core for data extraction, transformation, and reporting. So in your data analysis career, you see that SQL plays a pivotal role in the journey of a data analyst, because you use it in many instances where you are supposed to communicate with your database, to query data from the database, to extract, to transform, and to report. And why SQL is important for data analysis? We can use it to extract actionable insights from large data sets. It's easy to learn, and it's also powerful in practice. Use cases that you can use it in finance, business intelligence, marketing, HR, etc. And it's the interface with database systems. Is the language that communicates with databases, relational databases. So comparison of SQL with other data tools that we have Excel, Python, Power BI, among other data analysis tools that we have. We have a lot of them, so I've just singled out these four. So in terms of data volume, we understand maybe Excel has a limitation in that it carries around 1 million plus rows, but SQL, it's a high volume tool that you can use, whereas Python as well, it's high volume and with optimization. Power BI also carries high volume with import or with cloud or import mode, but it has some limitations. Then on data storage, this is relational databases. Excel is a file system. Then Python is any structured or unstructured data for machine learning and other analysis that you can do, for example, NLP. Then Power BI is data models, cloud and live connections. Then on automation, we use mainly stored procedures, which are moderate. Excel automation is low. Python is high. Script and pipeline. Power BI is high as well. Scheduled refresh and Power Query. Data cleaning. SQL is good because we use joins, filters, among other tools that we commands and tools that we use. Excel is manual, formulas and filters. Python is excellent. We use pandas and NumPy. Power BI is excellent as well. We have Power Query, which is also an engine that is in Excel. Then analytics power, SQL, strong, though we can't do visualizations, many of them, but we can do applications and joins and tables. Then Excel, yeah, they are basic. We have pivot tables and other charts. Then in Python, we have the analytics power is advanced. We use machine learning and custom logic. Then in SQL, sorry, in Power BI, it's it's a bit stronger. We use DAX and visual summaries. And also there's the functionality of embedding Python analysis as well in Power BI. Then on visualization, on SQL, it's poor. It's only raw data views. Then in Excel, it's moderate because we have slicers and charts. Then Python is I think it's medium to good because we have Seaborn and Matplotlib. Then Power BI is excellent. There's a number of visuals. Then the learning curve, SQL is easy to learn, easy to medium. Then Excel is easy. Python medium to advanced. Power BI is medium. Best use case, querying structured data. Then Excel, quick calculations and reports. Python, machine learning models and automation. Power BI, it's for business intelligence dashboards and executive reporting. Okay. Then we go to SQL syntax overview. So SQL syntax is divided into about 5. We have DDL, which is data definition language. Then DML, which is data manipulation language. DQL, data query language. DCL, data control. Then TCL is transaction control language. So on DDL, we have create, alter, drop, and truncate. So the purpose of this category is to define and modify database structure, for example, table, columns, and schema. Then data manipulation, we use it to read and manipulate data which is inside tables and views. So you see that most of the analysis that you are going to be doing, you are going to use a lot of DQL and DML, right? So on DQL, data query language, we have select and the other commands that are there. So you use this to retrieve and filter data from the database. Then data control language, we use it to control and manage permissions. Either we are revoking or granting permissions to a user. Then transaction control, the purpose is to control and manage transactions, either rolling back or saving or committing. So that's it. Then we have constraints. So on constraints, there are rules that help us to enforce data integrity and consistency in a table. They help us to ensure that only the valid and meaningful data is installed. So constraints can be defined at column level, applied to a single column, or table level, applied to an entire table. These are some of the constraints that we have. For example, not now. You see that maybe if you have dealt with the data before, it may have now values, but not now. Or in some instances where you are deploying your Google Forms, you can say this is mandatory. So in SQL, we can say not now. It prevents that data from having now values or empty values. Then unique ensures that all column values in a column are different, right? No duplicates. Then identity, it auto-generates sequential numerical number values commonly used for primary keys. You see that when you will be defining primary keys, identity can work there, or you can auto-generate or you can define, your own primary keys in a formula that you want. Then primary key, it uniquely identifies each row and combines not now and unique, right? To define a primary key. A primary key is a column or a unique identifier to a record. Then foreign key maintains referential integrity by linking a key to another table. So you see that, for example, you have your table of sales and your product. For those tables to communicate, they communicate via a foreign key. So a foreign key maintains referential integrity by linking a key to another table. Since our tables, they are linked to foreign keys. Then check ensures that values meet a specified condition. You can say check if it's a number, check if it's greater than 100, etc. Then default assigns a default value if none is provided. Create index, it improves performance for querying large databases. So those are some of the constraints, but I think there are some which are not included here. Then we go to database schema or the entity relationship diagram. This is important to understand this because it will help you when you are now querying your database. So entity relationship diagram, it defines the diagram or the relationship between the tables that are in our database. So at high level, we have a database. Then inside the database, there are tables and views that you can define. So these tables are related via keys, which we said are primary keys. So in an entity relationship diagram, it's a pictorial representation or a visual representation of how the tables in our database are related. For example, here, I've tried to simplify it in an education or education institution context, be it a primary school, a secondary school, or university or something, where we have teachers, we have subject teacher, we have subjects, we have students, we have groups, we have marks. So, for example, all teachers have their IDs or EC numbers, and a subject is a subject ID, right? So the subject table, for it to communicate with the teacher's table, they communicate via the teacher's ID, and we have a relationship there, which is a one-to-many, which means one teacher can teach many subjects. Okay, then students and marks. For every student, there's a student ID. A mark is a mark ID. So for us to identify which student has this mark, we refer using the student ID. So it helps us to define or to know the relationship, and we'll be using these relationships when we are defining joins in our scripts. So it's important that you understand the entity relationship diagram or the database schema. On the far right, I've tried also to show cardinality. So cardinality is either one-to-one, one-to-many, many-to-one, man-to-many, something like that. For example, an employee can only belong to a one team. A customer can have many orders. A department can have many employees. A student can enroll to many classes, something like that. So it will be a many-to-many relationship. Then you see that in Microsoft SQL Server, this is the typical ERD that's there. And the primary key is shown by a key in yellow. And for example, the geography and the customer, the geography key is the foreign key. That is the primary key of the dim geograph table. And in the customer table, it's a foreign key. Okay. So we'll be using that to do our data manipulation. So a database creation, in most cases, the database are normalized. That's the reason why you see that we have different tables storing related data. So imagine that in your company, every data of your organization is one table. It will be a mess and it will be difficult to deal with that data set. So normalization comes in to reduce redundancy and improve integrity, minimize anomalies and improve query performance. So we have first normal form, which ensures that our data is atomic values. Then second normal form, full functional dependencies. Then third normal form, no transitivity. And these forms, there are many. I think they go up to as far as voice code normal form, fourth normal form, and fifth normal form. Don't worry about the technicalities around this. You understand it in the next lectures. So I have tried to give an example here of normalization. So the first table is an employee and department combined, and skills. So we have employees, their department, and skills combined in one table. Okay, and you see that using only one table for the entire record. In the employee skills, we need to have redundancy there and duplication. In the department there, we can have duplications as well as in the location. So for us to avoid redundant and transitivity issues, we need to normalize, because a table that is not normalized mostly have these problems that are on the far right. One is insertion anomaly. If a new department is created but no employees is assigned to it yet, we cannot store its location because we need an employee record to insert. So it means we have duplications in our data at the end. Then update anomaly. So if the location of the HR department changes, we must update it in multiple rows for both Nick-wise and Lily case. Okay, so that's update anomaly. If one row is missed, data becomes inconsistent. So it means we need, if a record updates in another table, we need to be updating all the dependent tables. But if we normalize our data, we can use our keys to just query from the main table. It means we need only to update in one table. Then deletion anomalies almost related to the insertion or update anomaly. If all employees in the IT department leave, we lose the department information, including its location. If we delete or get rid of that record, then data redundant, the department location is repeated for every employee in the same department. That's the problem. If we can have maybe add a 50 employee from the IT department, we need to duplicate the IT department, right? Then after normalization, here we have our three entities. So entities in mostly they are objects or real world items. For example, an employee, a department, and skills. So you see that the employee, we have the employee ID, employee name, and department ID, which we then use to reference or to find the department for that employee. Then the department will have the department ID, department name, department location. Then on the employee skills, which were being repeated using those commas, we have employee ID and the skills. Employee ID and the skills, okay, that they have. So that's it. It helps us to solve a number of problems. Then SQL in the data analysis pipeline. So SQL is used for data extraction, transformation. We can use SQL plus Python, visualization, Power BI, Excel, Tableau, Python. We can use it to connect SQL Server to Power BI for live visuals as well. For those who have done Power BI, you can see that you can connect and filter your data using SQL. Then we have other items that are important: views, stored procedures, and common table expression. So what is a view? A view is a visual table based on the results of a SQL statement. So this is the command. Then stored procedures is a prepared SQL code that you can save so that the code can be reused over and over again. I'm going to show you how you can define stored procedures. Then common table expressions are a powerful feature in SQL that provides a way to define temporary result sets that can be referenced within a SQL select, insert, update, or delete. Then temporal tables is a special type of a table that is created and stored in the temporal database. So at high level, we have a database. Go to table. We go to views, temporal tables, common table expressions, and their level of accessibility, I think it's a bit different. How you access a common table expression is different from a temporal table, is different from a view, and is different from a table. Common pitfalls: avoid select all in production because it then impacts the performance of your database. Always filter in delete or update, because if you don't do that, it's either you are going to delete everything or you are going to update everything. Use aliases for readability. So an alias is like a nickname. You should use those, especially for your table names. Then index wisely for performance, and I think these are some of the performance tuning criteria that you can employ. Then online coding environments, I've tried to select this for some who may have problems. Then supporting materials, these are some of the supporting materials that you can consult or that you can use. W3 Schools, AdventureWorks Database, Allison, Udacity, Kaggle, and YouTube, of course. So I hope you are going to enjoy. Thank you.